Okay, so for question 5, we'll be working with radians, so keep the same setting on your calculator. So the diagram shows a circle with center O. The circle is divided into two regions, R1 and R2, by the radii OA and OB, where angle AOB is theta radians. The perimeter of the region R1 is equal to the length of the major arc AB. Pi I is asking us to show that theta is equal to pi minus 1, and double I is telling us that the region of R1 is 30 centimeters squared, and we have to find the region of R2. Correct to 3 significant figures, and we have the formula sheet that gives us the arc length and the area of a sector of circle in radians. So the arc length is r theta, and the area is half r squared theta, and I'll be showing you guys how to derive that. So the first things first, write down what you know. Very important. So we know that the perimeter of R1 is equal to the major arc of R2. We've taken this in IG before with the major arc and the minor arc. Major arc is just the bigger one, and that's all it is. Anyway, so we have the circle. I'll just draw it out for you guys. Okay, so you know how we've taken this in IGCC where theta over 360 times 2 pi r, which equals to the length of the arc, and 360 is the same as 2 pi, so theta over 2 pi times 2 pi r, and you're just going to simplify that, cross the 2 pi here and the 2 pi there, so the answer is just r theta, which is the radius times the angle. Literally, that's it. And then for the area, it's theta over 360, just write it as 2 pi times pi r squared. Simplify that, cross out the pi's, it gives you half r squared theta radians. And yeah, that's it. Okay, so now we're trying to find the perimeter of R1. Literally, r theta is r theta since we're not given any values. And then you're going to add the arc and the two radii. So it's just r theta plus r, or r theta plus 2r. And now I want to find the length of the arc of the major arc, right? So we all know the circumference of a circle is 2 pi r. So 2 pi r minus r theta, which is the arc of the minor arc, will end up giving you the major arc, and that's it. And now in the question it did say the perimeter of R1 and the major arc length are equal to each other. So what we're going to do is we're going to place an equal sign between those two equations. So r theta plus 2r is equal to 2 pi r minus r theta. And we're just going to move them all to one side and then simplify it. So r theta plus 2r minus 2 pi r plus theta r, don't mess up the signs. And we can just divide it by 2r since it is common in all of them. So then that will just leave us with theta plus 1 minus pi is equal to 0, and then makes theta subject of the formula or subject of the equation. So theta is equal to pi minus 1. And that's it for the first part of the question, and that is a total of 3 marks. Okay, and on to part 2, finding the area of R2. I will be explaining it further, just keep watching. So of course, writing down the most important parts. Area of R1 is 30 centimeters squared. So what in the world would the area of R2 be? So we can use the formula half r squared theta, and we'll try to find what r is since we do have theta now. And we have the area, so find r, the radius. So half r squared times pi minus 1 is equal to 30. We can just divide right away the 30 by pi minus 1, or we can just expand it like I did right now. So half pi r squared minus pi r squared is equal to 30. Take out r squared, which is the most common multiple here. So half pi minus half is equal to 30. Divide whatever is in that bracket by 30. Or sorry, divide 30 with whatever is in that bracket. So then r would be the square root of that value. And that will give you an answer of 5.29. Okay, so now that we have r and we have theta, we can find the area of R2. Well, the theta in this case will be different, and I'll explain that later. So half r squared theta, so half times 5.929 squared times pi plus 1 in this case, not minus 1. And it will give you 58.0, because they did say 2 3 significant figures. We're just going to keep it to that. And that is a total of 4 marks. Congratulations, we're done with this question. So we need the theta of R2 to answer this question, right? And we know from part I that the theta for R1 is pi minus 1. Pi is 180 degrees, right? So it's just a straight line. So the angle between BO and the line that I've just drawn and AO and the line I've drawn could be assumed to be 0.5 each, right? So that part is only pi minus 1. So you can assume right away that R2 is pi plus the 0.5 on each end, which is pi plus 1. Or another way that you can do this is take the 2 pi and subtract pi minus 1 from it, or the theta of R1. That's because a full circle is 360 degrees, right? And 360 degrees in radians is 2 pi. So 2 pi minus that of R1 gives you the answer of R2, which is also pi plus 1.